Saxon Advanced Mathematics, Lesson 90. We're going to talk more about identities. We have covered so far a list of identities that looks like this, right? We have our original trig functions. We have what we call the reciprocal functions. Then we learned these negative angle or even and odd identities where we figured out how minus signs work. We have these quotient functions that remind us that tangent is sine over cosine. Cotangent is that on its head. Those are helpful. Then we did these Pythagorean identities where we started with this one, which is kind of like a squared plus b squared equals c squared. We rearranged it, then we divided it by sine squared, and we divided it by cosine squared, and we got these 9 different variations, right? We also talked about these cofunction identities, that sine and cosine are related to each other's angles, tangent and cotangent, secant and cosecant. That's why they have that co in front of their names, right? It's because there's this complementary relationship between them. Okay, all of that is old news. Recently, we tackled what we call, oh, I put the wrong name on here. These are not called double angle identities. These are called sum and difference identities. They have to do with adding or subtracting two sines or two cosines, okay? And then we also used these as we were fooling around with them. These are the sum and difference identities that we learned a couple lessons ago and we are memorizing. These we need to memorize hard. Now today we're going to tackle what we call the double angle identities, and what's cool about these is we don't have to memorize anything new. What we have to learn how to do is manipulate these, mostly these, but we're going to use these 2 tools as well. We're going to manipulate these to get what we call the double angle identities without having to memorize anything new. This is crucial because we don't want to memorize any more than we have to, okay? So let me show you how we're going to develop those. Example 90.1. Develop the identity for A, the sine of 2A. Well, if you think about it, we can take our sum identity for sine, which we were just looking at, I'm copying it. I squished it. It's the first one that we learned, right? It's this one right here. Okay? Now, look at this. What happens if, instead of making this a plus b, what if we were to change this to be the sine of a plus a? Then all these b's would change into a's. Let's rewrite it. Sine of a cosine of a plus sine of a cosine of a. With all the b's turned into a's, these are exactly the same, and we can now say that the sine of 2a equals 2 times the sine of a and the cosine of a. This is the double angle identity for sine that we don't have to memorize because now we can almost do it in our heads if we just imagine. We can do it in our heads if we just imagine this one, the sum identity for sine, and we just change everything to a's, and then we realize these match and we can squish them together. Then we have this without having to memorize it, and that is ideal for us, right? Okay. That is for sine, and there is only one double angle identity for sine. You must be thinking exactly what I'm thinking, and that is there's a different story for cosine. Okay, so there's one double angle, that's what dA stands for, double angle identity for the sine function. Here's how we derived it. There's where it is. You shouldn't have to memorize it. You just need to do it often enough that your brain can do this automatically. Okay, remember, we are laying track here for calculus and advanced sciences where you're going to need to use these identities. So what we're trying to do is just get your brain up to speed on this and to say, it's not that hard. You can do this. If you memorize this, you can quickly create that. All right? Now we're going to do the same thing for cosine of 2a. So let me flip. This paper always fools me because it's so nice and thick. I think it's 2 pages. I'm so in love with my new notebooks. Have I said that? I know I have. B, we're still in the first example. Now we're going to derive the identity for the cosine of 2a. And our strategy is mostly the same. We'll take this sum identity with the a and the b. We'll write that first. So it was cosine of a plus b equals cosine of a times cosine of b minus sine of a sine of b, right? That one we know, that one we're memorizing. I know it, but that doesn't count because I've done this before. Okay, and now we're gonna flip all these b's into a's because we're gonna make it the cosine of a plus a. So that will be the cosine of a minus the sine of a sine of a, right? And now I can squish that in my brain. This becomes cosine squared a minus sine squared a, okay? That's an identity for the cosine of 2a. That's our other double angle identity, okay, that we learned to derive. Now, here's the thing. This looks familiar, doesn't it? This is the first, wait a minute, why is mine not right? Cosine squared a. Oh, right. Here we have a formula that we can substitute in for sine, and here we have a formula that we can substitute in for cosine, okay? So we're going to take the other forms of our Pythagorean identities, and we're going to substitute in for either the first part or the second part. I want to do cosine first, because that one's a little bit easier, okay? So we remember that cosine squared theta is how we've memorized it, equals 1 minus sine squared theta, right? That's another identity. So we're substituting that in just for this part. So now the cosine of 2a equals 1 minus sine squared, and we'll make it a so that it matches, minus sine squared a. See, this is the part that we substituted in, right? Cosine squared theta equals 1 minus sine squared. So there's the cosine squared, so now we put in the 1 minus sine squared. Oh, that's interesting. So then we get cosine of 2a equals 1 minus 2 sine squared a. Oh, this becomes the second form of the cosine double angle identity, okay? We use the Pythagorean to play around with these chunks. Well, we did this one. Now we're going to do this one, and that'll give us our third form. So there are 3 forms of the cosine double angle identity. Interesting. All right, so this is the first form. This is the second form. to derive the third form, we're going to go back to this, and we're going to remember that sine squared A equals 1 minus cosine squared A. And we're going to substitute that in now to this part. This will put back to what it was in the beginning, and we'll just change the other part. Hi, Grace has come to see me. Hi, Grace. How are you? Very good. Very good. Good girl. Stay right there. Stay right there. Good girl. Good girl. Good girl. She's staring at me. Okay, so we're going to plug this part in here. So our third form. Oh, did you hear that? Oh, that's such a cold nose. Hi, Sue. What's up? What is it? What is it? She's sitting by me and she's crying. She seems pretty happy, though. I think she's been outside recently. Her fur is cold. Good girl. Did you have your snack with your sisters? I'm just petting her. Sorry. Math has to wait. Good girl. Good girl. Everything's fine. Everything's fine, Sister Sue. Good girl. Gracie, drop. Good girl. Good girl. Wait till I'm done with the identities and then I'll deal with you. Okay, she's behaving. All right, so I'm taking the first form, I'm leaving this term as it originally was, and now I'm substituting one of my Pythagorean identities in for just that part. So what we get is the cosine of 2a equals, this stays the same, cosine squared a minus, and now we put this into the parentheses, 1 minus cosine squared a. This one's tricky because we have to be really careful with these minus signs, right? Because this will become a minus 1. This is going to become a plus and get added over here, right? Here, I'll just write it out. Cosine squared a, and then it will be minus 1 plus cosine squared a. So then I can add like terms, and I can say that the cosine of 2a, this is the third form, equals 2 cosine squared a minus 1. Yes. Double, triple checking to make sure it's right. Yes, this is right. So this is the third form. This is the first form. This is the second form, and this is the third form. I'm trying to make sure I'm pointing at the right things. This, yes, this is the second form, and then this is where we started talking about the third form right here, right? Okay, that's a lot, isn't it? That's a lot to remember. You can follow it, I'm sure, when I do it, stumbling through, but it's a lot to remember. So we're going to practice this and make sure that we understand it. All right, and we're going to use these second and third forms in just a few minutes in something else. But first, what I want to do in the next example is develop the identity for tangent of 2a. Now, John is not going to let us start. We know that we need to do this. It'd be the sine of 2a over the cosine of 2a. And we've already developed these in the first part, but John says, no, you can't just copy them. You have to rethink them all the way through. So, all right, fine. Okay, we have to go back to our sum and difference identities. First, we want to develop the sine of 2a. So let's look at the sine of a and b. Oh, that's right. This becomes a and a and a, so they're both sine a, cosine a, and we add them, and we get 2 of them. So it's 2 sine a, cosine a. And now we have to remember the cosine of 2a. We can use just the first form of it, but let's look at this. For the adding, let's see, that becomes cosine squared a minus sine squared a. Okay. right? That looks good. That looks really good. The only problem is with tangent identities, we always want to set the lower left term to 1. That one right there. So this is where I'm going to use a different color pen. Here's my orange one. We're going to divide everything by cosine squared A, because that will turn this into a 1. This, we also want to divide by cosine squared A. And also this, I'm going to squeak this in over here. But here, instead of writing it as squared, we're just going to write it out cosine of A times cosine of A. That's going to make it easier to cancel. This is cosine squared A, right? It's the same thing. So 2 terms on the bottom, 1 up top. We're just writing it differently on the top because it'll make it easier to cancel. Okay, this cancels and becomes 1. The minus sign stays. This becomes tangent squared A, right? Because sine over cosine is tangent. And then up here, let me just write this other part too, so you can see it all together. 2 sine A cosine A. I'm just rewriting that part, right? And then that's what we're dividing by, same as down here. Now look, this becomes 2 times the tangent of A. That's the numerator. This is the denominator. So we can say, I'll write it right here. The tangent of 2A equals 2 tangent of A over 1 minus tangent squared A. Yay, that's right. All right? That's an identity. We don't have to memorize it. We can derive it from, we can go all the way back to the sum identities for sine and cosine. Smush these in our head into the double angle version, put them out, divide them by whatever it takes to make this lower left term go to 1, simplify, and this is what we get. Oh, it's kind of fun, don't you think? It kind of makes your brain blurry for a while, but it's fun. Okay, those are the 3 double angle identities. We have sine, we have cosine and tangent, but then we remember that within cosine, we use this Pythagorean identity to rearrange it into different forms. And this becomes important. A part of me thinks, why? Why, John? Why would you do that? Why would we want to do that? We're going to use these 2 in the next problem, all right, the next part. And by the way, we're almost done. What we're going to do now, these were all double angle identities. Now for part B, we're going to do half angle identities. So we've had some angles where we said A plus B, and then we had difference angles, identities, where we had A minus B, and then we had double, we just did those. The double angles, that's 2A, and that we referred back to those, right? And now we're gonna do half angle, in which we're gonna measure them as x over 2, but we're going to say, and this will blow your mind a little bit, x over 2 is equal to A, and we're gonna be drawing on the double angles to get us there. Okay, that's kind of a roadmap of all the different identities we've covered in the past couple lessons. It's been a wild ride, hasn't it? We started out way slower and suddenly the pace has picked up and we're doing all kinds of crazy stuff, but it's okay because we're figuring it out, right? Okay. All right, in order to do half angle identities, what we need to start with we need the second and third forms of the cosine double angle identity. Okay, so what we're going to do is we're going to work through all three of them relatively quickly to make sure we understand, or to make sure we can still get them. Okay, here's the sum, so we know that we're starting from there. Cosine of A plus B equals cosine A times cosine B minus sine A sine B. This we have to have memorized. That's our starting point. Now we're going to mentally create cosine of double A. Okay, that does everything. Technically, we're doing this in our heads, but I'm writing it down because that's kind of hard. Then we simplify this, cosine squared A minus sine squared A. There's our first form. Then we recognize that we can take the derivations of the first Pythagorean identity. We'll start with cosine, we'll substitute that in, then we'll change it, then we'll go back to this one and we'll change out the sine, okay? So, to derive the second one, that will be the cosine of 2A equals, and this is 1 minus sine squared A minus sine squared A. So this becomes right? There's our second one. And then to get our third one, we go back to this, and this time we change the sine part. Cosine of 2A equals cosine squared A minus 1 minus cosine squared A, right? That's this one. Now this changes the signs, and we'll bring this one over here, so it equals 2 cosine squared A minus 1. That, I did show the steps, but I went fast this time. Okay, so now what we want to do is we want to take the second form and the third form, and we're going to, let me write them here. First one, so I'm rewriting these now. 1 minus 2 sine squared A is the cosine of 2A. Right, so that's number 2. I've rewritten that down here. And then here's number 3. Cosine of 2A equals 2 cosine. Okay, that's the third one. Okay, now we're going to take this and we're going to solve it for sine squared A. Ready? First thing we'll do is subtract the 1, right? Let's swim the 1 over. Cosine of 2A minus 1 equals negative 2 sine squared A. Now let's divide both sides by negative 1. Let's get rid of the negative 1 first. Then that becomes, these both change signs, so I'm going to put the 1 first now. 1 minus cosine of 2A equals 2 sine squared A. I'm getting close to running out of room. I don't want to. Now I'm going to divide by 2. It looks like this, right? And that cancels. I'm not going to rewrite it, right? So we have a fraction over here. That cancels out. Now I have sine squared A over here by itself. I need to take the square root. What in the world, right? Okay, and as I do that, I remember, oh, I'm going to have to do plus or minus. Now, what I have is I have the sine of A, I'm not going to write the A down, equals plus or minus the square root of 1 minus cosine of 2A over 2. But instead of writing the A there, which is what I have, I'm going to play this little trick, which seems like it's cheating, but it's not, is all I have to say about it. I'm going to change the variable from A to x over 2, okay, in both places. So this is going to become x over 2. And this A, where's my book? Okay, if I've got 2A and I decide to change the A to x over 2, see how it cancels? So this becomes the sine of x over 2 equals plus or minus the square root of 1 minus the cosine of x over 2. That is our half angle identity for sine. Crazy, right? That is completely crazy. Why would you need this identity? Why would you want to use that? We're not going to answer that question. I'm here to teach you how to derive it. When you study calculus, you will learn what to do with it, okay? And just like with all the other problems we've done this with, if you already know how to do the mechanics of the problem before you learn the whys, if you already know the hows before you learn the whys, it's going to make it so much easier, okay? So this is how you derive the half angle identity for the sine value. We took the second form, we rearranged it, and simplified, okay? We're going to do the same thing to get the cosine of x over 2. And we're starting with this, just as we started with this, okay? I'm going to cut, this is the third form, we derived it here. I'm going to take this to the other page. And I promptly forgot what it is. Cosine of 2a equals two times the cosine squared a minus 1. Let me just double check to make sure. Yes, that's correct. Okay, we're doing the same thing for this one. We're going to solve it for the squared cosine. Okay, we're going to rearrange the whole thing. So I'm going to add 1. This one's easier because we don't have a minus sign that we have to clean up over here. So that makes it easier. We're going to divide by 2. This cancels. Then I'm going to take the square root of both sides. Now I'm going to flip them around. This becomes cosine of A equals plus or minus square root of cosine of 2a plus 1 all over 2. So far so good, right? John likes to flip these around and make the 1 come first because that's how we did it here. So we'll do that on our next pass. It's typically written with the 1 first and then the cosine, because in this one it has to be that way. So I'm just going to rewrite that again so it looks the same. 1 plus cosine of 2a over 2. And then we're going to make that wacky change where we're going to say that a gets changed to x over 2. So then we have cosine of x over 2 equals plus or minus square root of 1 plus cosine. Now 2a becomes 2 times x over 2. The 2's cancel, and so it goes to just plain x over 2. And there is our half angle identity for cosine. We don't want to memorize it. We want to remember the process of how to get it. Wild, right? This is totally wild. This development will be required in future problem sets because it provides excellent practice in changing blah, blah, blah. I'm not going to read all that. What John is saying is we're not going to really use these identities the way we've used some of the past ones, but we're going to practice deriving it so that we get really good and really fast at it. And not like this time where we're, kind of like white knuckling it all the way through this crazy lesson, right? But this is the half angle identity for cosine. And this is the half angle identity for sine. We did it, yay. And we did it without any information other than our sum and difference identities and these two. This one we needed for the substituting, right? Go outside, breathe some fresh air, get something to eat, go pet your dog, listen to a symphony, paint a picture, do something right now good for your brain because I just gave it a vicious workout. That is the end of lesson 90. The next two lessons, I can tell you for sure, the rest of this week are not trig identities. We get to do something. I'm looking again. I say something a lot easier, okay? It's not until 93 that we come back to trig identities again. Yay! Enjoy. I'll talk to you soon. Bye.